Hi, this is Rutvik. Today I'm going to explain what is Pi4Micronaut and how you can use it to develop Java-based IoT applications. Let's get started. Internet of Things is one of the most interesting fields out there in the market. It's a network of devices for communicating and exchanging data. IoT is widely used in automation, remote control, etc. It brings significant advancements in making human life much easier. We are using IoT in our day to day life from smart home devices, improving our city's infrastructure, and many industries as well. Raspberry Pi is one of the best microcontrollers that's being used for IoT application development. It is compact, affordable, and powerful computer. You can get a Raspberry Pi for yourself for around 50 bucks. It's ideal for educational purpose, whether you are a hobbyist, and for industrial projects as well. Raspberry Pi features built-in Wi-Fi, Bluetooth for seamless connectivity. It consumes less power compared to our traditional computers. One additional feature which our computer lacks and Raspberry Pi provides is the GPIO. What is this GPIO? GPIO stands for General Purpose Input Output, which lets users to connect various hardware components and sensors. With these sensors and actuators, we can perform real world data collection and also perform actions which can be automated. Different Raspberry Pis comes with different GPIO pins. For example, Raspberry Pi 3 and 4 come with 40 pin configuration. This lets the Raspberry Pi to be a central controller for IoT devices. This opens the wings to learn and develop prototypes in the world of IoT. So what's the problem here? When it comes to interacting with these hardware components and sensors, there is a huge dependency on Python language. It's hard to implement the support for interacting with these components using traditional Java approach because we have to understand the anatomy of sensors and also requires the knowledge of different communication protocols like PWM, I2C, SPI that are required by the Raspberry Pi, which involves how GPIO pins are configured to power up the connected sensors or components. So here is a solution called Pi4Micronaut. It's an open source Java library which we made it available through Maven Central Repository that enables the interaction with the hardware components that are connected to Raspberry Pi via GPIO. It's the fusion of Micronaut framework and Pi4J library. It lets you to develop and deploy the hardware interfaces as microservices on Raspberry Pi. Pi4Micronaut is a one-stop shop where you can find the example implementation, how to set up the circuits, and the documentation as well. As I said earlier, use Micronaut framework along with the Pi4J library to develop the Pi4Micronaut application. These are the two pillars of Pi4Micronaut. Why we choose these two things? Micronaut is a Java-based framework that lets users to build microservice architecture to develop applications. These applications are lightweight, has fast startup times, and leaves low memory footprints, which is suitable for running on Raspberry Pi without any issues. On the other hand, Pi4J is an open source Java library that provides access to different hardware interfaces or communication protocols which are required to interact with the sensors that are connected to Raspberry Pi via GPIO. How did we develop this? Well, we choose Java for obvious reasons. We don't hate Python or against it, but considering Java developers in mind and to make it easier for them to develop IoT applications, especially if they use Raspberry Pis. We have implemented the functionalities to provide support for various components and sensors using Micronaut's microservice architecture and making use of the RESTful APIs which it offers to control these microservices. We then utilize the Pi4j library and its hardware interfaces to build the microservices. We build the whole thing and obtain a jar file which we are going to run on the Raspberry Pi. Why to use Pi4Micronaut? Pi4Micronaut provides a powerful platform for IoT developers to leverage Java's ecosystem. It enhances the productivity of developers, where they can focus on their own application logic rather than focusing on implementing functionalities of the hardware components. Pi4Micronaut makes it easier to manage and develop IoT services on Raspberry Pi. Where it can be used in various fields, like for the home automation systems, like home security systems, industrial monitoring and control. You can develop an applications for smart city infrastructure and also for educational projects and research purpose. These are the example projects. One is a home security application which we used various sensors like ultrasonic sensors and motion detection sensors to detect if a person is approaching towards the device, and if it comes it alerts by beeping by using the buzzer we have and displays a message like there is an intruder, and he has to scan a RFID tag to stop the buzzer. That's a home security project. And we also developed a lab automation project which is a mouse maze, where we assumed there will be a maze where a mouse enters and exits through particular points. We have attached two ultrasonic sensors to detect the motion of mice, and we have took the inputs of start and end time. Based on that, we are calculating how long does the mouse took to exit the mice. This is for a research purpose, and we named it as lab automation. And there is a one more example project called GitHub Measure. It's nothing but a fun project which I was actually working upon. It involves a button where if you click the button, it should merge a pull request which I have selected. Sounds interesting, right? And how Pi4Micronaut came to life? Well, with the collaboration of Open Source with SLU and Unity Foundation, all this started in late August 2022. Till date, two teams with a group of four undergrad student developers along with their tech lead contributed around 20 hours a week for almost 2 years. I am one of the tech leads for this project. We have released version 1.0 of Pi4Micronaut library on Pi Day, that is on March 14, 2024. These are the developers which you can see right here. And if you have any questions, you can reach out to them on GitHub. And you can see the Pi4Micronaut version 1.1 supports 16 components, and this is the latest version. These include push buttons, light switch, rotary encoder, RFID scanner, LED, RGB LED, LCD 1602, photo sensor, which is nothing but light sensor, touch switch sensor, active buzzer, passive buzzer, PIR motion detection sensor, ultrasonic sensor. You know this, right? Like ultrasonic sensor is widely used in the parking sensors. You can hear a beep. That's where it can be used. This is just an example. And we have support for tilt switch, micro switch, and servo motor. These are the useful links. One is for the documentation, and the second one is for the repository. Third one is the Maven Central Repositories link, where you can find the dependency of Pi4Micronaut that you can add in your project. Artifacts are nothing but the jar files which Pi4Micronaut provides that you can use in your projects. And before that, I forgot to mention one important thing. Pi4Micronaut doesn't work with the latest Raspberry Pi, which is Pi 5, that comes with a whole new architecture and not compatible with the existing application. Since we are using Pi4J library for GPIO access, which doesn't provide support yet. We are working on it, and we may provide support for Pi 5 in future. Wait for the update. This is a Pi4Micronaut documentation. Here you can find more about Pi4Micronaut, how you can use Pi4Micronaut library with step-by-step process along with the screenshots. And here we have API references for the components which we have provide support. These are the screenshots, and you can find here how to set up your Raspberry Pi and make necessary configurations to make your application work on Raspberry Pi. Here are the example applications which are developed using Pi4Micronaut library. Here you can find the currently supported hardware, and if you want to contribute to Pi4Micronaut library, we have it ready for you. These are the steps which you have to follow, and these are the communication protocols which we have used to develop the functionalities of the components. And these are the components. We have classified the components into two things based on its functionality, whether it is an input or an output. So for example, let's get into the push button. This documentation includes the step-by-step guide for setting up your circuits along with the schematic diagrams, commands to interact with the components, and example implementation of how you can define the configuration of the component. And here is an example controller class where it helps you to develop your application. This is a GitHub repository for Pi4Micronaut, and here you can find the latest releases. Currently, the current one is the version 1.1, and in the README you can know more about the Pi4Micronaut and the client information, who are the developers, what technology is being used, and here is architecture diagram. If you want to contribute to Pi4Micronaut, you have to understand this before you get into the development part. These are the example projects. We are using Micronaut 3.7.3 for the Pi4Micronaut development, and we are using Pi4J version 2.4.0. And if you wanna find the dependencies, and you can find it here in the Maven Central repository. These are the syntax which you have to include in your dependencies. You can find different ways based on your project. If you are using Gradle, this is an example syntax which you have to define in your dependencies. And if you wanna download the jar files as the libraries, here you can find them. That's it for this video. Thank you.